So substitution reaction of alkane. For example, methane. Methane, CH4. If methane react with chlorine, then what will be happen? This chlorine atom from the chlorine molecule, one chlorine atom, substitute one hydrogen from methane. So here, if one hydrogen substituted by chlorine, then CH3, there is no one hydrogen. Instead of hydrogen, chlorine will be here, okay? And the substituted hydrogen and another chlorine atom combined form HCl. If we see displayed formula, then it will be more clear. Look at, wait. For methane, displayed formula, 4 hydrogen, right? Plus, for understanding, if we use different color, then it will be easier. It is chlorine, okay? Now, look at. If this chlorine and this hydrogen, if this chlorine substitute this hydrogen, then it is displaced this hydrogen. Sorry, it will be chlorine. Okay, and this hydrogen and this chlorine, if combined, then form another molecule, HCl. Okay, so actually substitution reaction, in substitution reaction, what's happened? If in this substitution reaction, there is a substitution reaction of alkane, it is an example, like alkane plus halogen. For example, here halogen is chlorine. So if chlorine react with an alkane like methane, what will be happen? The chlorine atom will substitute a hydrogen atom. Okay. So for this chlorine atom come here, and this hydrogen substituted, and finally form HCl, and this is the main organic compound, and HCl is the byproduct. So this is chloromethane. Okay. So this reaction, there is a condition for this reaction. This reaction, without this condition, this reaction will not be happen. So what is the condition? Condition is UV light. Condition is ultraviolet light, that is sunlight. In sunlight or in UV light, this reaction will happen. In dark place, where there is no light or sunlight, in that case, this reaction will not be happen. Okay, so for this reaction, first point, what are the reactant? Look at reactant is alkane and halogen, first point. So here can be bromine. You can take bromine as a halogen. So halogen and alkane. Okay, reaction between halogen and alkane. These two are reactant, first part. What is the condition? Condition is UV light. What are the product? Product is chloroalkane. Look at it is alkane. It is halogen. The reaction, this type of reaction is, this is chloroalkane, like chloromethane. So we can write it's halogenoalkane. In unit 2, we'll learn it. The halogenoalkane, there's another chapter. This is halogen, it is but alkane. So halogenoalkane and hydrogen chloride form, hydrogen halide. Okay. So this is the main product. So look at, we can get halogenoalkane how? If alkane and halogen combined form here halogenoalkane. Okay. So this is the substitution reaction. So this substitution can, the further substitution can be happened. Further substitution means, look at in methane there are 4 hydrogen, right? So only one in this reaction, in one step reaction, what happened? The one hydrogen only substituted by one chlorine. It is calling chloromethane simply. Okay, or methyl chloride. So if we add more chlorine, excess amount of chlorine, then remain, there is this hydrogen or this hydrogen or this hydrogen also can be substituted. So we can write this reaction. Look at I'm writing the simple equation, not displayed equation. Look at, if this is CH3 Cl, if we add more chlorine in the presence of UV light, what will happen? More hydrogen, that is this more extra chlorine will substitute another hydrogen atom. So hydrogen amount, number of hydrogen reduces, right? So now CH2, and this hydrogen, the second hydrogen, will be substituted by another chlorine. So more chlorine here. Another chlorine means already one chlorine. So if come another chlorine, then it will be Cl2 and form again HCl. Okay. And this we can write another two equation. Look at, because there are two hydrogen remain yet. Okay. So CH2 Cl2, if we add more chlorine, then form CH Cl3 HCl. Okay, so it is chloroethane, methane, it is dichloromethane, it is trichloromethane. And the last equation also you can write, shortly you can write here, CH Cl3 plus Cl2, can you see? Okay, CCl4 is here. So last one is tetrachloromethane. Okay, so look at the four. This is the last substitution. No more substitution can be possible here, because in the last product tetrachloromethane, in tetrachloromethane there is no more hydrogen present, right? So here if we add more chlorine, no more substitution possible because no hydrogen present here. So chlorine can substitute hydrogen from the alkane. So if 4 hydrogen, so 4 time 1, 2, 3, 4, 4 time substitution possible. If more hydrogen, like if we add here not ethane, like C2H6, so 6 reaction possible. Okay. So more hydrogen means more substitution possible. Got it? So here main thing is if I review the whole reaction, it is a substitution reaction because halogen will substitute hydrogen from the alkane. What are the reactant here? Actually main is, it is the reaction of alkane with halogen in the presence of UV light. Okay, what are the product we are getting here? Halogen or alkane. Okay, so if we add chlorine, then we'll get chloroalkane, chloromethane. If we add bromine, we'll get bromoethane, bromomethane. If we add here, instead of methane, if we use ethane or propane or butane, we can use. Okay, so if you learn this equation, you can write that equation also. So what are the name of the product? Look at, it is chloromethane, it is dichloromethane, it is trichloromethane, it is tetrachloromethane. Di means 2 chlorine, tri means 3 chlorine, tetra means 4 chlorine. Okay, so this is the substitution reaction. Got it? Any question? So for further substitution, I'm not showing the displayed formula. So if you understood the first one with displayed formula, so second one, third one, fourth one in the same manner. Got it? Any question? Okay. So now we can start. I will show the mechanism. It is very, very important for the exam, the mechanism for this reaction. So first, we'll see the mechanism for the first substitution, not further substitution. Okay. Generally, in your exam, you will face the mechanism for this first reaction. Sometimes they asked about the further substitution. Okay, so what is the mechanism for this substitution reaction? What is the mechanism? So before starting mechanism, we should know the one term, that is homolytic fission. Fission means covalent bond breaking. Covalent fission of covalent bond. Fission means breaking. So here, like there are two types of fission. One is homolytic. homolytic fission. So in this reaction, we need homolytic fission. So before explaining mechanism, first I want to explain homolytic fission. So here, like chlorine, there is a covalent bond. So covalent bond, we know, sharing a pair of electron. So here there is a pair of electron. Now, if UV light attack here, then what can be happen? This bond can be broken. So when this bond is breaking, then what will be happen? This what's happened on the pair of electron. This pair of electron will be distributed into the two chlorine atom. How? This one chlorine atom, this one electron will go to this side and another chlorine will go to this side. Homo means same. So same means these two electron will be distributed equally. Okay, equally means this one electron will go this electron chlorine and another electron, there is these two chlorine atom getting one electron equally. For this it is called homolytic, that is this bond broken and pair of electron distributed equally. Okay, then what will be the product? So this chlorine atom, first chlorine atom getting one electron and second chlorine atom getting another electron. So this and you can write like in this way, just okay, later I'm showing it. So here simply two, this is called free radical. We are getting two free radicals. So what is free radicals? Free radical is a species with unpaired electron. Look at this electron not in pair form, not in its outer shell, its surface of the chlorine. Okay, so this chlorine atom with unpaired electron, so it is not now atom or it is not charged. Sometimes you know if any atom gain electron or loss electron, it's from charge, positive or negative charge. But this free radical, this is not ion, this is not atom, this is a different type of particle. This is called free radical. What is free radical? It's a species or particle with unpaired electron which have no charge. Okay, so here we are getting two free radical. So this is homolytic fission. So by homolytic fission, the covalent bond breaking and the electron distributed equally, and we are getting two free radical. So in that case, one important thing is these two atoms should be same. Otherwise, homolytic fission will not be happened. If these two atoms are different, then heterolytic fission will be happened. How? Heterolytic. Though we do not need heterolytic fission for mechanism of substitution reaction, but together we can learn it. For example, HCl. In HCl, the hydrogen and chlorine different atom, they have different electronegativity, we know. So what is electronegativity? Already you know from bonding chapter, the electronegativity for an atom, it is the ability for the atom. What ability? To attract the pair of electron, that is shared electron, covalent bond electron, this bond pair electron. Okay, so ability to attract the bond pair electron in a covalent bond. So we know the chlorine have a higher electronegativity, right? So chlorine can attract this electron more strongly than hydrogen, right? So this electron will go to the chlorine side. Okay, so if this bond broken and this bond pair electron will go to the chlorine, then what will be happened? Here, chlorine getting this two electron. So it is negative charge. And hydrogen, no electrons, so it is positive charge. That is here formed ions, positive ion and negative ion. And why it is called heterolytic? Because when covalent bond is breaking, 2 electron of the bond, covalent bond actually going to the one electron, one atom. That is here electron distribution after breaking the bond not equal, unequal. Okay, for this it is because hydrogen not getting any electron, but chlorine getting 2 electron. So for this it is called heterolytic. It is not equal. Homolytic means homo means same, hetero means different. Okay, so here same distribution, here different distribution. Okay, so here another thing is curly arrow. Look at this straight arrow we use generally reactant to product, right? But this curly arrow, look at here we use double-headed curly arrow. Here we used single-headed curly arrow. So what is the difference? So first thing, curly arrow means if double-headed curly arrow means single-headed or double-headed. Curly arrow means movement of electrons. So if we use curly arrow in any mechanism, it means it is movement of electron. Okay, and now single-headed and double-headed, why? Here double-headed means this 2 electron, a pair of electron movement. Here pair of electron is moving, and here single electron moving. Single head means single electron moving to this direction. Here single head means this electron, that is this single electron is moving to this direction. Okay, so single head means single-headed curly arrow means single electron is moving. Double-headed curly arrow means 2 electron or pair of electron moving. Okay, so now if we see the mechanism of this substitution reaction, for this reaction mechanism. So there are 3 steps. Step 1. Step 1 is initiation step. Okay, so in this step, what will be happened? The UV light will attack the halogen. There is chlorine-chlorine bond. So in that case, already if UV light attack here, so here heterolytic fission will be happen. So already we explained. And if heterolytic fission happen, then 2 chlorine free radical form. Okay. In step 2 is propagation. Propagation. So what will be happened in propagation? In propagation, there are 2 reactions. First reaction, this chlorine free radical. Okay, I need the space actually, so I can erase the whole thing. For second step, first step already discussed, so I am going to step 2, propagation. First step, just we are getting free radical. Okay, in second step, this free radical, chlorine free radical, attract the methane, alkane. Okay, because in substitution reaction, the reactant was, what are the reactant? Methane and chlorine. So first UV light attack the chlorine molecule and form free radical. This free radical is unpaired, so it is exciting state. Okay, so it will attack and it wants to become paired, right? So it will attack the methane molecule and form, look at in methane actually, for understanding I am showing this part, the displayed part. In methane actually, in this case, for example, if this bond, there is a bond pair electron, okay? So if here heterolytic fission, homolytic fission form, then what will be formed? There is a methyl free radical and a hydrogen free radical, right? So this hydrogen free radical and this chlorine free radical form a HCl, and here form methyl free radical. Okay, because this hydrogen has a unpaired electron, hydrogen free radical, and this chlorine free radical has unpaired electron. So when these two combined, then this unpaired electron and this unpaired electron combined form a paired electron, that is form a covalent bond, HCl. And this methyl part, it is now free radical. Okay, so this part not showing, no need to show, just for understanding I am showing here. So this free radical, methyl free radical form. So now this methyl free radical will attack another chlorine molecule. Okay, so this chlorine molecule means in UV light, presence of UV light, this chlorine, this means actually there are two chlorine free radicals, right? If it is, there is a homolytic fission in chlorine molecule, where we'll get two chlorine free radicals. So now look at when methyl free radical and this chlorine combine, then what will happen? This one methyl free radical and one chlorine free radical combine, because there is unpaired electron, there is unpaired electron. So this one unpaired electron and another unpaired electron combine form a pair of electron, that is form CH3 Cl. There is a bond, there is a covalent bond. Okay, there is a pair of electron formed here, like here in HCl, a pair of electron formed. So another what will be left? Another chlorine free radical left here. Okay, so this is propagation step. Why? Because look at, in this case the reaction not finished, because we started the reaction with one chlorine free radical, and at the end of the reaction we are getting another chlorine free radical. That is, it's like a chain reaction. That is, it will continue, it will repeat again and again, right? For this it is called propagation step. So I'm telling again, look at here, chlorine free radical from the first step, we're getting this chlorine free radical attack the methane, and in methane there is a carbon hydrogen bond homolytic fission from methyl free radical and hydrogen free radical. That hydrogen free radical react with chlorine from HCl, and here methyl free radical form. And this methyl free radical attack the chlorine, and here also two free radical, there's chlorine, two free radicals. So one chlorine free radical and one methyl free radical combined form methyl chloride, there is chloromethane, and another product is chlorine free radical. Okay, so this reaction is chain reaction and it will repeat again and again, because product is a free radical. That is, we have started with chlorine free radical, and finally we are getting also, we are closing this second step with the chlorine free radical. Okay, any question in this step? Understood? Okay, I hope you got it. Now last step, step 3, termination. Termination means it will stop. How? There are three possibilities, there are three possible combination. In propagation step, one characteristics of the propagation step, out of in the two reaction, there are two reactions in the propagation step, and if we see the product side, there is a there is a methyl free radical, there is a chlorine free radical. That is, in propagation step, in product side we will get a free radical masked. But in termination step, we are getting that is reaction will not continue, right? That is terminated. So in that case, no free radical will produced. That is, in reactant side can be free radical. That is, two free radical combined form a molecule. For example, look at here, there are two free radical. We got one is methyl free radical, another is chlorine free radical. So these two free radical, if combined together, then what will be happened? Look at CH3 and chlorine free radical, if combined together, then form, there is unpaired electron, there is unpaired electron. So combined together means form CH3Cl. There is a covalent bond, right? And if CH3 free radical and CH3 free radical, these two free radical, same two free radical combined, then form CH3, CH3. This unpaired electron combined form a one pair. and 2 chlorine free radical if combined, then what will be formed? Chlorine. So these 3 reaction possible in termination step, right? Because there are 2 free radical, and these 2 different free radical can combine, and 2 same free radical can combine in the 2 reaction. There is 3 total reaction we can get here. Okay, got it? So main product is this one, and this 2, we are getting a byproduct. So if we summarize these steps, the 3 steps in the mechanism. So in first step is the initiation step, where UV light attack the chlorine molecule and the homolytic fission happen, form chlorine free radical. And in second step, the propagation step, that free radical attack, chlorine free radical attack the methane molecule and form methyl free radical and HCl, and that methyl free radical attack the chlorine molecule again and form methyl chloride, chloromethane, and form chlorine free radical. That is the chain reaction form. And in step 3, we're calling it termination step. So in termination step, what will be happening? In reactant side, always 2 free radical combined. Okay, and in product side, no free radical will form. So 2 free radical combined form a molecule. Okay, so here methyl free radical and chlorine free radical can combine, or methyl methyl or chlorine chlorine. That's the combination. So these 3 steps you have to learn. Okay, this is the mechanism for substitution reaction. So there are for further substitution reaction, there is another mechanism. There is in same way we can explain the further